Thank you so much for coming. My name is Coquiero and responsible for the Solutions architecture team here in AWS, helping customers from government, education, non-profit organization, healthcare in their journey to the cloud. And today, I have the privilege of sharing the stage with Uriol, who is the director for the Universidad de Monterrey. And together, we'll just tell a story about how you can use machine learning in order to make the people's life easier. That's the story today. And like any kind of story starts by the chapter 1. And chapter 1 is what machine learn about and how machine learning can make people's life easier. And I could spend hours talking to you about all the definitions, but let's do it in a funny way. Let's pretend for a minute that we are responsible to develop a solution to deal with Rubik's Cube. Rubik's Cube basically is a game that you just need to turn horizontally and vertically all the faces in order to make all those things the same color. That's our goal. And if you try to take the traditional approach of having all the imperative code using if, then else, I'm sorry, you probably will be in a very big trouble. Because the amount of combinations is about 43 quintillions of, 43 quintillions of different combinations that you have in order to address this very simple problem. So what should I do? Try to think in a different way. Basically, take a different approach. Instead of trying to define all the rules, the idea is how can I provide the data and then let the machine learn through the data in order to bring the result that you want. How you can do it? So the first step is about models. How can I create models, which is such an important piece when you talk about machine learning? And models need data. So data is the first point, because if you don't have proper data, probably your model won't be efficient enough. So as soon as you have the data, the second step that you can see in the middle is the algorithms, is the way that the machine will learn. And the machine actually, about this point, work in a very similar way when compared to us. For example, I have the basic knowledge about Spanish, but I was never a Spanish speaker. Means that my brain works in a different way in comparison to you, who was born and raised in this country. For the machines, it's the same. Depends on the context, depends on the data, they will take a different approach in order to learn how to deal with some specific problem. And as a result, as the algorithms, what you have is a model, which is just basically a step-by-step or a sequence of instructions about what the computer needs to do in order to bring the result that you need. So as you have those points working together, you need to ingest data. And going to the second step, it's about training data, training your model. So as you receive the model, you need to have some way to identify how good your model is in terms of bringing answers. In that case, you have our model being right in a 1% of the cases. Probably is a useless model. But as we move more and more data, our machine starts to learn based on the previous experience. And then more and more, what happens is just improvements about how much data, how much previous experience we are ingesting the machine, and machine learning, instead of trying to memorize the sequence of steps, try to generalize a solution that can bring an answer to the problem. So in that case, we have a confidence about 95%. And the next question is this accuracy good or bad? And the answer is depends. Because if you're talking about systems for fraud, let's talk about federal government in order to avoid any kind of tax evasion, it's a good number. 95% detecting frauds is very good. But if you're talking about facial recognition to identify crimes and people who commit crimes, Probably this accuracy is not that good. It's much more comfortable if you have something about 99% or higher. That's how machine learning works. So how you combine the solutions. For our case specifically, for our business case, 95% is good enough. And then is the time for the show, the time to get your model and then expose your model as an API. It's the time to see machine learning working. In that case, you can plug your model to some legacy system, but you also can use some techniques like IoT, Internet of Things, in order to interact with your model, which is exactly the example that you see now. So what you can see here, the integration between machine learning and IoT. Machine learning, you send all the commands that the IoT needs to do, and then what happens is something like that. Done. Is machine learning for real. Just send the commands and take the actions that I believe doing in a much faster way than probably most of us would take to do this problem. But maybe start challenging me now, saying like, hey Alex, get it. But you know what? Providing solutions for Rubik's Cube is not enough to make people's life better. I agree with you. Let's see a real example about someone who applied the same concept, but for real use cases. In our example, I have from Dr. Ali Parsa, and this example is about healthcare. In this example, Dr. Ali Parsa is a chief executive officer from Babylon, and what he did was a different way that patients can talk and interact with doctors. Instead of going to some hospital, they just talk with a device like this one, the Alexa device, which is our voice assistant that helps in terms of integrating several functions like play music, see your agenda, call to your friend, or helping in terms of how you can talk with the doctor. Interesting here is what you see now is not only the way that the patient talks, but in a background, you see what happens behind the scenes. What happened internally in order to provide the answer that the patient is asking for. Let's do it. Pay attention in the voice of Alexa.
Alexa, I want to talk to Babylon.
Hi there, I'm Babylon and I'm here to help. To start, tell me what symptom is bothering you the most.
Well, I've got quite a sore stomach.
Sorry to hear that. Let's figure out what's causing your pain and how to treat it. Chris, where exactly is the pain?
It's kind of on the top part of my stomach, sort of in the middle.
And how bad is the pain?
Oh, it's not too bad.
And does it come and go?
Yeah, it comes and goes, and it's worse after eating.
I see. How would you describe the pain?
Sort of feels like a burning pain.
Okay. And are you feeling sick?
Yeah, a little bit.
Have you vomited at all?
No?
Have you noticed you're feeling fuller sooner than usual?
No.
How long have you had this pain?
A few months? 3 months, maybe?
Are you still a non-smoker?
Yes.
Okay, that's great. Have you been taking any of your ibuprofen tablets the last few days?
Yeah, I have.
Thanks, Chris. I know enough now to offer information on what may be causing your symptoms. It could be acid reflux or a peptic ulcer. I'd recommend speaking to a GP soon. They're likely to prescribe something called a proton pump inhibitor to control your stomach acid. I can then get this prescription to your home using your Amazon Prime.
Okay, thanks, Babylon.
My pleasure. Thanks for using Babylon with Alexa. Goodbye.
The question is, those things can change the society that we're living now? The answer is for sure. And not some proof of concept or from demo, it's real. So this application is available today for about 10% of people who live in the UK and some communities in Africa in order to make healthcare more accessible for many, many people. The same thing, did you notice a small frame that talking about accuracy? It's the same concept. The machine behind the scenes was checking what's the best answer possible and then provide all the communication that the person was talking about. Imagine it for every single context of business that you have today. Change completely the way that you live. But let's keep doing it, because actually Dr. Ali Parsa is not alone. You see, you have many other customers using machine learning on top of AWS. Companies like NASA in order to help the space exploration. But in our other spectrum, we have companies like Tinder to help to find people that you love. You see the extremes, but both using the same concept, machine learning with models and bringing the results. But today, it's about building things. And to build things, I'd like to go to chapter 2 of our story. And the chapter 2 is, let's see things working. Let's see how we can develop, because it's the proposal of this session. And to develop something, or to develop a solution, you need a business problem. And our business problem today is about healthcare. And just to be fair, I know that many people here is not from healthcare, no problem at all, because you easily can take those concepts and apply anything that you can imagine. But about healthcare, I want to provide a better patient experience. And how I'm planning to do it? First, I have some forms or some documents, because every single government agency has documents. And in a traditional way, you receive documents and you start to have an operator type all those informations, because many hospitals are not integrated each other. What do? You just use machine learning to A, move this information to the cloud, and B, extract all the information from these documents. As soon as you have the basic information about the patient, the second step is try to combine some medical information about specific patient, getting some information about different devices that we have in a hospital. And then you create two models together. The first one is about fraud, because unfortunately, many people sometimes try to take advantage of our healthcare system, and you want to identify the fraud as fast as possible. And the second one is about not making people's life easier. It's about saving people's life. Because we want to identify the breast cancer, and we want a machine go there and saying, this person has a cancer, this person has not. It's our goal today. Let's do it together. And as soon as I have all this model working, we will expose it as an API. And I'd like to expose in two ways. First, using one legacy system. I have a legacy system in my computer which has a record about all the medical patients to see that don't need to change completely. Your organization can be something gradual. As well as Alexa, I want to provide a different customer experience for my patients. Because you know what? Builders build. That's the message that you hear today, this morning, and I will talk more and more over the session. Builders build means Amazon believes that machine learning can change the world, and we also believe that it's something so powerful that should not be only in a data scientist's hands. Should be available for every single developer, every single builder that can create some amazing solutions. You see, that's the proposal. It's our goal as a company, how to make it available for every single developer. And you do it basically classifying our solution in 3 different categories. The first one is the core infrastructure that you have available, all the frameworks in market like TensorFlow, MXNet. In terms of software, you also have available hardware like GPU, CPU based on Intel, that you have the computer power and the frameworks to develop whatever you think in terms of machine learning. It's the area that you have full control of your infrastructure. The only problem is this approach requires specialists. And you know what? You never have enough specialists in the market. Think about it, Amazon provides a second layer or a second category you call as a machine learning as a service. That you provide a managed service that people can go and develop the models without worrying about all the infrastructure behind. We just encapsulate the infrastructure for the solution perspective. And the third one is about AI as a service. That as an Amazon, we just went through all the steps about ingest data, creating the models, and we expose things to you as an API. And for you, you just need to know how to consume this API in order to make your business faster and easier. Basically, today I will cover the first two. I will show one example about AI as a service, and I will show one example about machine learning as a service. And our first example is about getting a form. And now it's time to see some things in terms of demos. Our demo now is basically I receive a one healthcare form, like this one, and I extract all the intelligent information from this form. So could you switch back to my computer, please? Could you switch back to my computer? Oh, it's there. Thanks. So here, what I have is the AWS console that will have all the services available. One of the services we call as a textract is the one that I mentioned in a PowerPoint slide. So the idea is how to extract information, meaningful information from documents. So what your application you do is something like that. First, you need to move the document to the cloud. And the way that I do it is just uploading the document. Here I have the document in my machine specifically, and I'm moving this document to the cloud, like what my application was supposed to do. And then my process starts working, and work in a way that able to analyze all the document that I have. And as you can see here, is a traditional document. So there's a name of the patient, there's an address of the patient, the medical information, very free form that people can provide whatever they want. So here, I just made a mistake because I uploaded the wrong form. Mexico Summit, data set, yes, it's this one. It's a healthcare, it's not insurance. So now they start processing all the form, as you can see. And maybe you can think about, hey, Alex, it sounds for me like a OCR. OCR is something that has been in the market for years and never worked well. What's the difference? Because instead of taking the approach of OCR, just reading and finding for text, the machine learning model will go to the document and identify what the meaning of each section of the document. Because the machine learning understands how this document works. So here, he just finished the process. I see that it has a lot of information here about the document. And here, the way that the machine learning just extracts information and creates to you all the text that you need. If you go here to the table, a form, look what happened. We had no structure before. He just extracts the information, say, hey, this form, there's a field, which is the name of the patient, address of the patient, and then I'm able to identify where this person is. In that case, the name of this patient is Maria Fuente. So imagine in your organization for every single form that you have, just ingest your form, and magically you have those information available for you that you can input in your database and do whatever queries you are looking for. Great, we have the form. Now could you switch back to the presentation, please? So now what you do is with identifying this person, it's time to do something more, or basically go one level up. One level up means, in that case, you just use a model that was created before. What about create your own model based on your data? Is our next step. And we focus on fraud. I'm really looking forward to see if this document is a fraud or not. But as you can imagine, it's impossible just look at the document and say, is a fraud or not. It doesn't work in that way, because fraud, there's a lot of circumstances that you can work. So in that case, let's use machine learning to help us to identify the fraud. And the way that to do it is using a service we call as Amazon SageMaker. Amazon SageMaker is a platform that allows you to develop all the models that you are looking for. So in terms of model, there are 4 major steps about getting information available, building the model, training information, and make it available as an API, which is exactly the same steps that you saw in Rubik's Cube. And when you think about create a model, the first step is try to understand what data do you have, because this one's key. If you don't understand the data, probably the model won't make any sense for you. It's exactly what you do now. In terms of interface, Amazon allows you to use your own development tools, or you can also use some popular tools like Jupyter, because we based our solution on the open sources, and we want to make things open for you to decide what makes sense for you in terms of business. So in that case, let's go and see the data scientist interface. Could you switch to my computer, please? And then now we are going to the Jupyter. Here we are, moving away from the text extract and going to SageMaker. In SageMaker, we have a first option here, which is SageMaker Studio, that has your IDE, integrated development environment, that you can create your code. And if you're not a developer, don't worry, because I will show different ways that you can do it. But here I have 3 users, and one of those is my data science for Mexico Summit. And I will just open the studio. And I don't know if you noticed, but for any moment I spoke about install servers, or Linux, or Windows, or libraries. That's the magic about managed service, because we have all those things for you, and you can focus on your business. Here you have the sequence of steps that you can do using Amazon SageMaker Studio. And the first one that you do is create a notebook. Notebook is where you will just go and write our code. It's one of the options that you have. The next question here is, okay, what kind of environment I'd like to use? Maybe using some Python library is one option here. If you like to use R, there's an option as well in a different configuration. You can use MXNet, PyTorch, TensorFlow, are all the options available in the market today that you can use. In my case, I will focus in Python. And here we are. We have our developer environment that you can do codes. And let's code together. I hope everything works. The first point about coding is like how to import all the instructions that you have. So here in Amazon, you can integrate libraries like Bolt3, which is the library that allows you to integrate with all the Amazon services. Or you can use some open source libraries like Pandas, which is this one. You are free. It's all about freedom. You can use whatever makes sense for your business. And now I want to visualize the data that I have. So the way that I visualize here is just reading the information that I have in the cloud. And when I run my code, what I have here is I just reading all the data sets. It's here, the data set, which has information with cases with fraud and cases that we have no fraud. They have both together. And as you run the code, what you receive as a result is a data frame, which again is an open source structure. Now I just run my code. It's time to see what I have inside. So the data that I have now is the patient number, race, gender, age, emergency. And interesting, because I'm mixing here information about social context, as well as insurance, like payer code, as well as information about, here is about diabetes, like tolamazid, hexamide, sitagliptin, insulin. All those things are things that's about the specific patient. And in the end, what I have is this field. Because some specialists, usually a human person, when they say, hey, this case is a fraud, this case is not. So I just know what happened in the past. Could you switch back to the presentation, please? At this moment, we know the data. We understand what we have in hands, we organize all the data. It's about going to the second step, which is building the model. To build the model, there's several algorithms available today. You can use things like XGBoost, which is an algorithm that helps when you have a linear problem. For example, the example that we are working now is a linear problem. I want to identify is a fraud or not. It's a binary result. But you also can use something like k-means, which is the second example, the second column, that you can use for example, identify how coronavirus, yes, coronavirus here as well, can spread around the world. Because I know what's happening now, but how can I know about the future? And machine learning can help you when you use the second column. Or you can use convolutional neural network, with the third one. It's about read image. We'll talk more about it soon. And the last one is about how to organize information, like LGA, like we receive tons of documents, and we want to classify those documents automatically. So these are the options that you have. And just a small fraction that's much more available in the academia, in the market, in a GitHub, that you can use embedded in this environment. In order to make it faster and easier, we will use a feature from SageMaker that we call as a SageMaker Autopilot. So the idea of SageMaker Autopilot is go there, analyze your data, do all the transformation that you need, and in the end, build the model to you. Let's do it. Let's do it together. Could you please switch back my computer? Because now it's time to create things. Good. Let me just make it a little bit bigger. Here, the button that we create, experiment. Because actually, there's no magic model. Go there and magically create things. What the machine needs to do is like, hey, I have your data. I want to do many experimentations to see which model works better for my specific case, for my specific reality. I create my experimentation, and now I do these very similar steps in comparison to what I have done before. First, define a name for the job. So, Mexico Summit, healthcare fraud. Second, I want to define where my data is. So I have a storage on the cloud that has information about my data set, which is the same that I show you in a code, patient medical requests. I define which field in my column is the target, what one I want to predict. In that case, the name of the field is fraud. We showed you in a demo before. And finally, as soon as I get those results, I want to put in a different area that I can analyze later. In that case, I put as an output. So very straightforward. Hey, A, provide me the inputs, tell me what I need to predict, and then where should I put the results. And for me, when the magic happens is now. We have several models that you can use. You can define, hey, SageMaker, go and do things automatically, or if you know the problem that you are looking for, just select what you need. In that case, I know that's the binary because or the document's fraud or it's not, so I just select the binary in order to do the analysis. And I need to define a metric that helps me to understand how good is my model. Here we are, the accuracy. You see the same idea of Rubik's Cube, but now in my model. So as soon as I define all those steps, it's just about running my experimentation. And behind the scenes, there's all the process to mining the data and test about 250 options to see between all those options, which one is the best one. As you can see, a lot of knowledge about data scientists, but just embedded in a tool to accelerate your productivity. And if you say, okay, but I want to see what's happening because I don't like black box. I don't like either, by the way. So what you can do is, if you go to experimentation, here I have one that I ran before starting this presentation. Usually takes about 2 hours to go to run all these 250 models when you use the automatic option. And here on this model, they have several experimentations, which says, okay, what are the results for every single combination that I tried? And if I classify here, basically based on my objective metric, which is the accuracy that I have in my data, automatically I suggest for you which one works better, which is this one. So as you define which one works better, your last step is here, this one. Your last step is, now I have my model done, just deploy the model. And when deploy the model, this model will be available as an API. So my model, define the server that you need, and then just deploy the model. It's how easy machine learning can be. From the analysis to development to deploying production, all the steps integrated. Could you switch back to the presentation, please? And just to be fair, you have all the code generated, you have access. So now we spoke about Autopilot. What about stretch us a little bit more? And what we want to do now is work not with text or tabular data. I want to work with images. That's our next step. So what we're planning? So we use the same SageMaker, but instead of using next, finish, all the steps automated, we want to develop every single step to see how it can work. Because in the end of the day, it's all about options for you. So let's do it. Let's do it together. So could you switch back to my computer, please? And when you check all the options for SageMaker, we have another option which we call as notebook instances. This one is also an interface. The difference is they provide more flexibility for you to customize your own environment. And here I have different notebooks that I can use. One of the customizations that I can do is the kind of the interface. Actually, this interface is the one that I like most. It's more simple, but it's very handy when you think about developing code. And what I have here is one notebook which shows how I can show a specific image. If you check here, I have about almost 200,000 exams that there's no cancer, and I have about 8,000 of exams that has a cancer. So I just put those both together, and for each one of those occurrences, the one that has cancer and the one that has not, that was evaluated for a doctor, that's the image that I just mixing. So for us, or if you are not doctor, probably you'll see here and say, hey, no way for me to identify any cancer there. But if you are radiology or has experience, look at that. And you spend hours and hours and check, hey, this one will have a cancer, and let's work on it. So we are doing the same thing that a human person does, but in that case, you do it with the machine. Now let's go to the model or to notebook that helps to develop the model for cancer prediction. And the first step is about configuration, which is basically says where this data comes from. We need to do it in order to do the analysis that you need. So as soon as you have the data, in that case I use some breast cancer cancer histopathology, which is here. This data is available in my cloud account. My next step is, okay, what kind of approach I like to take? Remember in a previous example, I select like binary classification. Here, I'm using or I'm coding image classification because I want to classify images by cancer or not. So I define some parameters that I can use, and as soon as I have these parameters which says things like, hey, how fast I want to learn based on this model. We'll just have the process to create the job, or the process to ingest the information and get the results out. So here we are. Here is where the magic happens from the code perspective. Estimator.fit. Fit is when you send this command to say, okay, now it's time to learn. And then they use all the algorithm before and do all the process to bring the result back. I know the result doesn't sound like beautiful, but it's really, really cool. Because there's a lot of information here which show each step about the learning process. Here, I start the learning process, step 1, and you can see the computer learning some specific experience. As soon as you have the experience done, could you switch back to my computer to the presentation, please? As soon as I have the model done or going to the process to learn through the data, the last step is exposed as an API. So the idea here is just use some DevOps or development and production techniques to make it available at scale. So what you do now is like just moving my model and moving it to production. Going back to the demo. Here we have several models that I created during the preparation for the demo. If I just go to the end, because I run the code before, you see that I have a breast cancer model, and just need to go here, click and say, hey, move to the production. My API in production. And you might wonder, hey, is the same that you showed before? Yes. Before I showed in Amazon Autopilot, everything automated. Now I'm showing how you can do things for real or things like in a very low level model. So as soon as you have the model and you have it created, just about creation, create your endpoint, and then you finish your process running all your entire endpoint. And you can define like, hey, I want to have something like multiple servers running at the same time, or I can run one per time. You define your strategy in terms of moving things to production. Going back to slides. Now we are going to the end, because now is the time to use everything that you developed so far. So, and we will use this information in 2 ways. The first one, I want to integrate that API with the legacy system, because yes, we have a lot of legacy system. Let's go into the demo. I have my legacy system here. It's like a very traditional, I'd say, user interface for people to develop. We have a lot of those interfaces nowadays. And then the doctor can go there and select, okay, patient A, Maria Fuente, patient B, Sue Sanchez. Okay, I want to analyze the patient A. And then all the exams that we, as people, or even the doctors, look at those images and say, hey, I have no idea if this person has cancer or not. And then you just go there, click in a button, and then invoke the API that we created before. In that case, unfortunately, those images has a cancer. If I change for Sue Sanchez, this combination of images has not. And this point for me is key, and I'd like to pause to get your reflection. Because sometimes people just go there and use this system without realize what you have behind. Because from the user perspective, it sounds like any kind of legacy that you have. But behind the scenes, instead of waiting like 3 weeks for someone going there and do the analysis, we'll do it almost immediately. Like imagine that case, breast cancer, specific for women, go there and right after leaving the room, hey, I have your result in your hand. That's changing people's life. That's change the way that you live. And then going to a challenge now, our last challenge, which is about Alexa. Let's exercise, let's stretch ourselves to do the same that I did before, but instead of using a legacy system, using some voice interaction. The same information, same API, I will just show in a different way. In order to help me on it, I have Alexa here. And what I will do is a simulate operation as if I were a doctor. So imagine that I am in my clinic and I want to know the results, and it's time to see those results. Alexa, iniciar Dr. Guru.
Bienvenido, Dr. Alex. Hoy tiene 2 pacientes, María Fuente y Sue Sánchez. ¿Cuál le gustaría obtener más información?
María Sánchez.
Las cosas no van bien. Hay evidencia de cáncer de seno en su examen. Mi recomendación es reservar un tiempo con ella lo antes posible.
Same interface. That cause is the size of the revolution, because you just create a much better customer experience. In that case, for the doctor, just get the information faster and faster. So that said, I'd like to invite someone to the stage, which basically did it for real, which is Daniel Uriol. He was in a keynote, and he has been doing amazing things for Tecnológico de Monterrey. And please, Daniel, come to place and then show us what we are doing here in Mexico. Please. Thank you.
Thank you, Alex. Bueno, voy a hablar en español. Alex os estaba hablando de muchos casos en los que él de algún modo cree que podemos evolucionar los servicios de inteligencia artificial. Yo os vengo a hablar de cómo ya lo estamos empezando a pilotear y a mover en el TEC de Monterrey. No sé si estuvisteis en la anterior keynote que yo di, pero en esa keynote nosotros lo que hacíamos es que todo lo que hacemos lo hacemos piloteándolo primero y testándolo con alumnos. De esa manera tenemos los datos y cuando lanzamos algo, lo lanzamos convencidos de que eso es la solución que nos va a funcionar como esperamos que funcione. Eso es precisamente de lo que os vengo a hablar ahora. ¿Qué estamos probando? Tenemos, por ejemplo, una cosa muy básica. Tengamos primero en claro quién es quién. Y estamos utilizando un servicio como Recognition dentro de lo que es la nube de AWS para poder identificar las personas que aparecen en las imágenes. Con esto estamos empezando a desarrollar servicios. Desarrollamos servicios, por ejemplo, para pasar, por ejemplo, lista en clase. Y además, de hecho, luego os voy a hablar también de otro que también encaja muy bien, ya podemos empezar a identificar, como os decía antes, la persona que está en el mundo físico con las personas que están en el mundo virtual. Y cuando una persona entra en un campus ya tiene la capacidad de podemos ver qué comportamientos tiene, qué necesidades tiene, qué patrones de conducta tiene, todo bajo principios éticos y dándole siempre el control al alumno de que él pueda en cualquier momento decir, ¿sabes qué? No quiero compartir ninguna información más con vosotros. O sea que en ese sentido también nosotros somos muy cuidadosos. Pero ya estamos de algún modo con estos servicios identificando a las distintas personas dentro de los propios campus. Sabiendo cuáles son las personas, nosotros tenemos la capacidad de poder empezar a ver en función a la información que tenemos de ellos cuáles son los gustos que tienen. Y en función de los gustos que tienen, tenemos la capacidad de poder empezar a hacerles sugerencias. Sugerencias que ellos no esperan. Sugerencias como, por ejemplo, en este campus va a haber este tipo de eventos. Este tipo de comida es la que nosotros empezamos a proporcionar y como ahora mismo sabemos que tú te has metido en un plan que puede ser a lo mejor de dieta o lo que sea, podemos decirte que quizás vete a esta cafetería que tiene este tipo de menús más adecuados para para ti o no. O incluso estamos proponiendo, oye, ¿qué tipo de grupos te pueden interesar en base a lo que son tus intereses? Ese es el proyecto Me Conoces. Posteriormente, estamos ya incluso partiendo de una base en la cual no queremos matar a las personas a base de preguntas. Hoy en día todo el mundo, pues cuando quiere saber algo de las personas, lo que está haciendo es, te pregunto, te mando formularios, te mando encuestas, te hago... Eso al final a los usuarios les acaba molestando mucho. Es mucho mejor observar lo que están haciendo. Tenemos de algún modo, con Deep Lens, distintas formas de identificar cuáles son los gustos y las preferencias que tienen cada uno de los usuarios. ¿Y cómo lo estamos haciendo? Pues estamos montando, antes os hablaba de un proyecto, lo mencioné muy rápidamente, se llama Gravity. Gravity es una red social que hemos creado para los alumnos. Normalmente la mayor parte de las compañías, cuando quieren saber algo de los clientes que tienen o de los futuros usuarios, pues se lanzan a internet a ver qué información pueden recabar. Nosotros lo que hemos hecho es al revés. Hemos dicho, vamos a hacer algo que ellos nos empiecen a regalar su información, y creamos una red social. Y en esa red social los alumnos comparten contenido, comparten gustos, comparten cosas que les interesan. Y todo lo que hacen, aunque ya lo saben, lo estamos analizando. Entonces, si de repente un alumno empieza a postear muchas cosas que tienen que ver con deporte, no tengo que preguntarle si a esa persona le gusta el deporte, ya lo sé, su contenido es de deporte. Y con este tipo de distintos elementos vamos tagueando a las personas para saber cuáles son sus preferencias. Eso es el proyecto del que estoy hablando ahora. Esta es la red social de la que os estaba hablando. Esta red social, es muy interesante la historia que nosotros hicimos. Al principio nosotros nos planteamos utilizar, pues no sé, un mod de cualquier otro tipo de plataformas, ¿no? Pero realmente nos dimos cuenta de que ninguno se ajustaba a lo que nosotros queríamos, porque nosotros elaboramos todo con una plataforma en la nube y lo hacemos a base de microservicios. Y esos microservicios son básicamente diseñados por los propios alumnos, con lo cual hicimos un análisis con alumnos de las plataformas comerciales que existían ahora mismo y nos dimos cuenta de que en el mejor de los casos el 40% de la funcionalidad que traían de esas plataformas los alumnos no les interesaba. Con lo cual íbamos a hacer un gasto muy grande y además íbamos a poner a su disposición muchas cosas que realmente no pedían y no necesitaban. Creamos una red social y todo lo que son las distintas funcionalidades son los microservicios que desarrollamos con los alumnos y por los alumnos, porque también los alumnos pican código y los alumnos nos ayudan a desarrollar todo esto con APIs públicas que tenemos. Después de eso, nosotros ya estamos viendo cómo podemos empezar a conectar cosas. Y una de las cosas que a Alex le va a gustar mucho es que en el gran data lake que nosotros estamos montando ya estamos conectando el mundo físico y el mundo virtual. Una de las cosas que él está hablando es cómo Alexa te puede dar respuestas. Y eso está muy bien, pero nosotros vamos un paso más allá. A mí lo que me interesa no solo es saber las respuestas que Alexa le está dando a los alumnos, sino qué preguntas los alumnos le están haciendo a Alexa. Porque si yo sé las preguntas que los alumnos le están haciendo a Alexa, yo sé cuáles son sus intereses, yo sé cuáles son sus necesidades y yo sé cuáles son los tipos de servicios e información que debería estar dando en ese mismo momento. Y ese tipo de información ya las estamos conectando con S3 y estamos teniendo la capacidad de poder también unirlos al perfil de cada una de las personas. Porque Alexa, al empezar la interacción que tienes, te pregunta ¿quién eres? Y en cuanto a quién eres y le dices cuál es tu matrícula de alumno, ya todo lo que tú hagas con ese Alexa empieza a quedar registrado en ese data lake que nosotros estamos haciendo. Además de eso, con esa información ya empezamos a saber lo que la gente está haciendo en la app o en la web y además lo que la gente le está preguntando al propio Alexa. Con lo cual empezamos a ver que aunque la gente no esté interactuando propiamente con esos devices digitales, ya cualquier cosa que vaya haciendo en el mundo físico, por así decirlo, también queda registrado y nos genera una data muy interesante. Y por último, estamos empezando a utilizar también Face Recognition. Face Recognition informando en todo momento a las personas que van a estar metidos en un programa de Face Recognition, posibilitándoles que si deciden no participar en él, lo puedan hacer de la manera más sencilla e incluso con un simple botón borran toda la información que tengamos de ellos, con lo cual en ese sentido no hay ningún problema. Pero los que sí deciden hacerlo, y cada vez son más, De repente empezamos a ver cómo en el acceso a los edificios ya podemos saber quién accede y quién no accede. Y podemos saber también qué salas usó y cuáles no usó. Y por tanto podemos empezar a hacer algo que queremos y es precargarle toda la información del setting para cuando vaya a utilizar una sala de reuniones sabemos, está llegando Daniel porque hizo la reserva de la sala él y por tanto él necesita esta presentación, él necesita 5 sillas y él necesita todo este tipo de cosas. Ese tipo de cosas ya lo estamos viendo y por tanto cuando ya tengamos todos esos datos organizados y ya lo estamos organizando, empezamos a tener patrones de conducta y podemos empezar a hacer predicciones con respecto a las distintas funcionalidades que van a tener. Con lo cual, al final, en base a todos los datos, lo que buscamos es siempre generar muchos mejores servicios, más acertados, más predictivos y sobre todo teniendo el feedback constante de los alumnos y de los colaboradores para los que trabajamos. Muchas gracias.
Thank you. Thanks so much. Yeah, and going to the end, here's the link, ml.aws, that you have available, and you have all the demos that I showed today, a lot of step-by-step that helps you to learn as well. Finally, if you are interested to take some trainings, you have machine learning trainings specific for you to go and do what I did today with much more detail. That said, thank you so much. Gracias and have a great event. Thank you.